All right, hi everybody. This is the Math 31 Exponential and Logarithmic Functions Review. This is question 4a. Determine the intervals of increase and decrease, the maxima and minima, concavity, and points of inflection for each of the following functions. Okay, so here we go. So this is the first one that we're going to look at here is an exponential function, okay, e to the negative x squared. So to find the intervals of increase and decrease, the first thing I'm going to do is take the derivative. And because this is the exponential function, okay, the derivative of e to the negative x squared is going to be e to the negative x squared, multiplied by the derivative of the exponent, in this case negative 2x. So this will be negative 2x e to the negative x squared. Now, for me to figure out the intervals of increase and decrease, I first of all have to figure out where this is equal to 0. Okay? But actually, this is incredibly simple because e to the negative x squared, just think about what the function y equals e to the x looks like. It never hits the x-axis, okay? It never actually does go to 0. An exponential function can't unless it's been transformed. So in this case here, the only thing that's going to cause this to go to 0 is when x is equal to 0. So the only place that occurs is where x is equal to 0. Now, think about the way the number line works here. Okay, plug that in. If I choose a value less than 0, now up here it doesn't matter. Once again, on the exponential function, this is always going to be positive. So the very nature of this is going to be positive. So if you choose a negative value for x, it doesn't matter here. It is going to matter here. Negative x times negative 2 will be positive. So it's going to be positive here. And if you plug a positive value for x in, again, it doesn't matter what's going on here. This is going to make that positive again. That exponential function is not doing much here. But the negative 2 times a positive will make this negative. So this is going to be increasing on the interval negative infinity to 0, and it will be decreasing on the interval 0 out to positive infinity. Okay, so increasing and then decreasing means that we are going to have a max at x equals to 0, and the coordinates of that point will be 0, comma, well, just go back up, whoops, to the original function, plug a 0 into that, and you're going to get 1. So there you go. So now let's check the concavity. So take the second derivative. Now that first derivative has created a product here. So now when I take the second derivative, I got to be aware that I'm going to have to use the product rule. So the derivative of negative 2x will be negative 2 e to the negative x squared plus, now I'm going to take the derivative of the exponential function. What that's going to do, though, is it's going to leave me with that e to the negative 2x. Sorry, e to the negative x squared up in the exponent here. But it's going to produce another factor of 2x out front. So multiplied by the 2x that's there, that's going to get me 4x squared. Okay, so now the second derivative is a little bit more complicated. And just for the sake of simplicity here, let's factor out the... Well, let's be lazy here. Let's leave the x squared as positive. So let's factor out a 2 e to the negative x squared. Okay, now that's going to leave me with negative 1 plus 2x squared. All right, good. I am going to set this equal to 0. Okay, because we're going to, again, to figure out the intervals of a concavity, I need to figure out where the second derivative is equal to 0 first. Again, notice that the exponential function, the 2 in the exponential function here won't do it. It's got to come from here. Okay, it's got to come from the polynomial. So 2x squared minus 1 equals 0 means x squared is equal to 1/2, which means x has got to equal plus or minus 1 over root 2. Okay, so now let's just take a quick, let's just think about this real quick here. If we look at the number line, negative 1 over root 2, positive 1 over root 2. Okay, if we pick a number in between these two, for example 0, and plug that in, 2 times 0 squared, okay, is going to be 0. This is going to be negative, so it's going to be concave down in between here. Now I suspect that it's going to be positive outside of these two, okay, but I don't know. So let's just think about this. Pick a number less than negative 1 over root 2. For example, let's pick like negative 10. Okay, it's pretty sure that that's going to be fine. So negative 10 squared is going to be 100. 200 plus -1. Yep, positive out here. And because of symmetry, I can do the same thing. I know it's going to be positive out there. So this tells me, okay, and I'll write this over here because I'm going to, well, I'll write it over here. It's going to be concave up on the interval -infinity to -1/√2 union, okay, +1/√2 out to infinity. It's going to be concave down on the interval between -1/√2 and +1/√2. And that's going to give us points of inflection at -1/√2, comma. Okay, well, I got to go back up to the original function here. And if you plug -1/√2 in there, this is going to basically get us 1/2. So this will be e to the -1/2. And honestly, both of my points of inflection are going to have the same y-coordinate here. So just to make this a little easier to write, this is going to be plus or minus 1/√2 e to the -1/2. Okay, they're both going to look like that. And there we go.